Hi, welcome to my new unit on related rates in Calculus 1. This is the first video, and it's on the derivative in respect to t. Here we go. The derivative of a function in respect to t. Find each d dt in relation to L, which could be the length. So, as in the past, we used to write, and I'll do the first three like this, and then I'll stop doing it because then you know how to handle it. So dl dt times d dl times L. So I change d dt to dl dt d dl, and the dl's cancels out, leaving you with the d dt. So we have dl dt. The derivative of L in terms of L is 1, so that becomes dl dt. So I'm going to show you this 3 times, and then I'm going to take a shortcut. So what about doing the derivative d dt on 4s, where s could be the length of a side? Again, we write d ds dt and d ds times 4s. So that's d ds dt, and the derivative of 4s in terms of s is 4, so this becomes 4 ds dt. So that's the derivative of the side in terms of t. Now we have d dt in respect to r, so we have dr dt times d dr times r, so that's d dr dt, and the derivative of r with respect to r is 1, so this becomes dr dt. So that's doing the derivative in terms of t, time, which is related to the rate. So now let's do it faster this time. So now we have d dt in respect to r, so that means let's do the derivative with respect to r. So the shortcut is the derivative of r squared in respect to r is 2r, and we have to go dr dt. So if this was dr with r squared, we get 2r, but because we're doing it in respect to time t, we do the derivative of this function, which is the 2r, and we go dr dt based on this, what we have shown you up here. Number 5, do the derivative of a in terms of t. We would get the derivative of a is 1, and we get dA dt, so that would give us the derivative of the area, if a is area, in terms of time. And the same for number 6. We have the derivative of the volume in terms of time, if v is volume. The derivative of v is 1, so that's dv dt, so that's just becomes dv dt. And we do some more examples to keep showing you to make sure. What about if we do the derivative of L times W, which could be interpreted as length times width, in terms of t? So this is a product rule, and in this case, because it's a product, is P and G, so we'll go the d dt on the L, and let's do it, show you this way, times the W, plus we get L, and we get d dt on the W. So we do the derivative of L first. So the derivative of L is 1 and dl dt times the W. Now we have, oops, put an add there, almost made that here. That's L. So we get the derivative of W in terms of t. So the derivative of W is 1, and it's dw dt. And to tidy that up, we would have W dl dt plus L dw dt. Again, working out the derivative in terms of t before we get to word problems to do examples. Number 8, where we do d dt on 4 over 3 pi r cubed and 4 over 3 pi is a constant, so that's 4 over 3 pi. I put the constant in front, and we do the derivative with r, so that's a 3r squared. So it's 3 moves in front, and it decreased by 1. 3 minus 1 is 2. And we have a dr dt. And when we tidy that up, 3's cancel out, so we get 4 pi r squared dr dt. And the final example, to keep explaining, we have in relation to the sum, we got a d dt on these two polynomials or terms. So 2 pi r squared plus 2 pi rh. So we could interpret this as the area of two circles, and this is the lateral area of a cylinder. So that's what this means. But when we do this, because it's an addition, we do each one separately. So I'm just writing this down to make sure everything is explained. d dt, so 2 pi rh. So the derivative of 2 pi r squared, 2 pi is constant, so we put that in front. Derivative of r squared is 2r, and it's dr dt plus. Now, right here, we have a constant, which is 2 pi, and the ins right here, this is a product of two functions, so it's a p and g. So we do the derivative. Let's do d dt on the r, and we'll put that in brackets, times h, plus we have r times d dt, which is the derivative of the h. So we do that. So to tidy all this up, we have the derivative down here, so that's a 4 pi r dr dt. And right here we have, we do the derivative here first. So we have a 2 pi, and we'll do right here, the derivative of r in terms of t is, derivative of r is 1, and that's it, dr dt times the h, plus we have r. The derivative of h in terms of t, derivative of h is 1, and we have dh dt. So that's the derivative of the product. And again, this is already simplified, so we get 4 pi r dr dt plus 2 pi times this term here, we get 2 pi h dr dt plus 2 pi times this term here, we get 2 pi r dh dt. Again, this is a derivative of a sum, but within this derivative here, we have the derivative product also. So we notice also, this is dr dt. We can't combine these because they're not like terms. We can factor a little bit, but we can't add these together because they're not like terms. So that's just doing the derivative of d dt1 to help you understand before we get to word problems. And again, if you like my video, click on the like button, the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.